Hey, wouldn't that be so cool if we could try out different multiverses and meet ourselves?
That would be fun, but different dimensions only exist in movies.
Not necessarily. Yeah, it's also in shows and books. That too, but some theories may have given hints of different dimensions, such as string theory. String theory? Like guitar string? Exactly. Like a guitar string can create different sounds depending on the vibration. In this theory, elemental particles, or the particles that make up atoms, are not a point, but a string, and depending on its vibration, it can create a certain kind of particle, such as a lepton. But why is this theory needed? Before that, let me give you a bit of history. In 1974, John Squires and Joel Schreck developed a theory of one-dimensional strings making up the universe. This theory was able to explain a mathematical model that described the scattering of particles called mesons. This model is known as the Vinzeno amplitude, discovered by Gabriel Vinzeno in 1970. However, later scientists found out that this theory was able to merge quantum mechanics and relativity, or in other words, able to bring gravity into the pointing of elemental particles, possibly becoming a theory of everything. But its two main problems is holding this theory back. The first problem being it is impossible to prove this theory as these particles are too small to test with or prove. Second, there isn't enough space for these string particles to wiggle around mathematically. Our world has four dimensions: length, width, and height and time, as we know of. However, string theory needs at least 10 dimensions, based on the superstring theory. So scientists discovered a solution. Like how we can create three-dimensional paintings on a two-dimensional paper, mathematicians Theodore Kaluza and physicist Oskar Klein found out it was possible to add a fifth dimension to the math in our world. But Yana, we can't see these other dimensions. Yeah, that's right. Humans only see a small percentage of the universe, so there's a possibility that these extra dimensions are hidden from our eyes. However, like when we get closer to an object, we can start viewing 1D to 2D and then 2D to 3D. At a quantum state, it is possible to observe these extra dimensions based on the superstring theory. Regardless, we need five more dimensions anyway for this theory to work. That's why scientists believe these extra dimensions may be coiled up into one singular fifth dimension in a process called compactification. Think of like a length of a rope. Although it appears to be one long rope or an object, on close inspection there are hundreds of tiny threads alongside each other. Whoa, that's so cool. So what would these extra dimensions look like? Imagine you have a paper. There are so many ways you can fold it. You can fold it like a hot dog, like a burger, like a donut, etc. Now replace this two-dimensional figure with a six-dimensional figure. This figure could be coiled up in endless ways. However, there is a rule that helps filter this endless possibility scheme called the Calabi-Yau manifold. Calabi-Yau manifold allows vibration to pass and the string theory to work by usually removing the first Chern class, which describes the twisting of the manifold. However, there are still roughly 10 to the power of 20,000 possibilities, where each figure gives rise to a distinct physical phenomenon and universe with their own set of laws and constants, or in other words, another dimension. Okay, but that's like crazy. I know, and that's the magic of physics. It is literally the path between sci fi and the real world.